Alright, it's been a while since I posted, and learning about the brain is taking forever for me to do. It's a really vast subject, and I have a goal to try and post something once a week, and I feel like I'm starting to fall behind, so I thought I might be just kind of post up random videos here and there of just cool things in the body, or about science, about medical, and I don't know, I might make something of it and do these types of videos more often, just kind of keep them simple. So, with everything going on, sorry, I'm a little out of breath, I just ran. But with everything going on today with COVID-19, talking about vaccinations and all this crazy stuff going on, I thought it'd be cool to maybe talk about vaccination just a little bit and just kind of take a look from the scientific perspective of actually what happens with the vaccination. There's obviously a lot of opinions about vaccination. I have my own, which I'll refrain to the best of my ability from getting too into. I'd like to, at least in this video, just have it focus on the scientific aspect and then the morality of it and whether or not it's good for your body. Yeah, this is a different subject. But if you want to comment on it, that's awesome. I enjoyed the discussion. I definitely had my opinions about it. So granted, this will be a very brief synopsis of vaccinations and how they work. The subject of vaccinations and immunology fills volumes of books, and I am no expert on it. Everything that I'm bringing up here is just off of what I've already learned in my few classes that I've taken in physiology, anatomy, biology course that I took that we went over it a lot, and and in the spirit of me getting ready for class in pathophysiology and medicine, I'm getting more geared up for learning these types of things. So I'm excited about it, and I'll just kind of give an overview. Okay, so first things first. Before I actually go into the vaccination, there's a couple important things to understand. Okay, so there's different types of cells in your body. All right, so. And that marker is not working. I have no idea why, you just barely used it. Okay, let's try this one. Okay, so, here we go. Alright, you have in your body B cells, cute little guys. And we'll use this color here. And then you got T cells. Okay? And let's imagine, if we will, that this is an arm right here, a very beautiful arm with, here we go, massive biceps. Okay, there you go, big triceps. Okay, and then this guy gets a little cut right there. Gosh, I gotta find a better place for my markers for this stuff. Okay, and yada yada, blood coming out. Okay, so if we take the inside of this area here, inside the cut, blow it up. Okay, and so let's say that this is the top layer of the skin. We have a perforation here, and we'll say that this is like a nail. Okay, I know we're looking at it really close. So this is the tip of a nail right here. Okay, and it goes into the skin. Okay, deep enough to cause some damage, and pathogens can get in there. And then let's imagine that we have this little guy, and give him a little angry face, sharp teeth, there we go, little arms, mad little guy there. Okay, that's the pathogen, right? Of course, he wants to do damage to the body. There's so many different types of pathogens, bacteria, viruses, they want to do things in different ways, and they'll function in different ways. A lot of different mechanisms to take over the body, to even use the body's own immune system against itself. Okay, again, that's when it gets a lot more complicated. We're not going to do that. We're just going to keep it simple. Okay, when it goes into here, you have cells called macrophages. We'll draw a big one here. Okay, macrophages are big suckers. Okay, you also have mast cells all over in the skin. Mast cells are everywhere. Those have a different function. They're the immediate response, or the first response. Actually, the second response. Your first response is the top layer of your skin. Second will be this area, and then third is your immune system. Okay, so anyways, mast cells, they secrete histamine. That's why you get inflammation, redness, Okay, they also secrete certain chemicals to bring white blood cells to the area of infection through a process called chemotaxis. Um, Macrophages, they swallow the bad guys up. Okay, they swallow those buggers up. And you also have what are called dendritic cells. Okay, a lot more kind of a star shaped on the dendritic ones. Okay, both of these things have a term called APC. Okay, these are APC cells, which means, if I can even remember it, antigen presenting cell. Okay, so what is an antigen? Well, an antigen is a specific group of protein, sugars, fats, or whatever, just in any organization. Okay, we actually refer to them as PAMPs. It's probably another word. It's kind of cool to know. Okay, PAMP stands. Oh man, I don't want to write it all out. Okay, forgive me. I'm short and simple. Pathogen associated molecular pattern. Pattern associated molecular pattern. I think that's it. Okay. So it's a molecular pattern within the pathogen that these things will recognize, okay? And what they do is they actually will engulf it or undergo phagocytosis, okay? Where they engulf this little bad guy, so he's inside here after being engulfed. And they completely dissolve him up, eat him up, and they'll actually present a little part of him on the outside of the cell. This is why it's called an antigen presenting cell, okay? It presents it on the outside. Now the macrophages and the dendrites kind of do it a little bit differently. Okay, the macrophages will present it to these T cells right away, if there are T cells in the vicinity. And then those T cells will proliferate. Now, proliferate means to segregate. So they'll multiply, okay, separate into these, okay? So cytotoxic T cells. You might have also heard of killer T cells, that's what those are. Regulatory T cells, okay, and also helper T cells. As the name implies, helper T cells help. They actually help B cells and help B cells proliferate, okay, and they help B cells give off antibodies, okay, which I'll talk about in a sec. Okay, so the dendrite will actually go through the lymphatic system, go to a node, which is where these cells are, okay. You've probably heard of lymph nodes. You got them in your neck. You can actually feel them here in your groin area, a couple other spots, okay. And they'll go to there and they will present this antigen. And if a B cell gets it, it will proliferate into plasma, B cells, and memory B cells. Okay. Which reminds me, there are actually memory T cells as well. Okay. Yeah, there's a lot. This system is huge. I'm not even covering a minute fraction of the amount of things that happens in the immune system. But these are the basics for vaccination and how it works. So through these processes, plasma B cells, these guys will produce just tons of antibodies, okay? Antibodies serve as markers on the bad guys, so they'll attach to them so other ones know to go to them to phagocytose them. And they might also destroy them themselves. The antibodies themselves might destroy it, okay? They kind of work in different ways depending upon what the pathogen is. So when it comes to a vaccination, the key is the memory B cells and the memory T cells, okay? Now, I can almost guarantee there's a lot more to it than that, but based upon my limited learning and knowledge, this is what I've got so far. So after the infection is done, all of these other cells and stuff, they'll just kind of die off, okay? Helper T cells will die. After the infection's been fought off, these things kind of leave the system, okay? And it takes a while for the body to actually produce all of these different things to get to the point where the virus can be killed off, It takes a while. So once you've gone through that time of infection and you've produced memory B cells and memory T cells, these guys actually stay in your system for years, a long time. So what happens, see, maybe I can get a little space down here. Here's this here. All right. So let's just kind of imagine a little chart here. See if I can do this off of memory here, give a good idea of what happens. So the first time you're infected, we'll say, I'm making up this graph on the spot. I didn't even think about this before this video, so bear with me. Rate of infection, okay, the time that you have the disease, okay. We'll go with over time. I'm not sure if time will be right. I'm going to erase this for now. Okay. So you'll get the infection. Okay, so we'll just start up here. Okay. You have the infection, and then your immune system will kick in, and then the infection will go down, and then it will be gone. Let's see. You know what? I should have done this a little bit different here. That's not going to explain what I'm getting at. Let's talk. So this x-axis here, we'll call this immune response. Trying to wait for my brain to pick up on what I'm thinking here. Okay. So the immune response will start off slow the first time, okay, because you're building up all of these cells that you need, okay. And then eventually all those plasma B cells and killer T cells will go around, and then your immune system response will kick up here, okay, and fight off the infection. You'll have a bunch of memory cells, okay, in your system after that first infection. So the next time you're exposed to that specific antigen, okay, it's going to have a really, really fast immune response because you already have those memory cells that remember that disease, okay, it remembers it. So as soon as it touches it, your immune system is ready to go because it's already encountered it. And then those guys will start proliferating like crazy. So really what it comes down to is the vaccination speeds up the natural process of what your immune system already does. You're using your own immune system to fight the disease. Even without the vaccination, this exact same process is what occurs. So if you have the virus just naturally and you beat it, this will happen. And this is why, like in under George Washington, people found constantly with smallpox that once they got it, they were safe. Is because they had this really strong immune response. And yeah, I think that's it. Cool stuff. Hope that gives just a brief idea on the science behind it. And yeah, I hope it's cool to you as it is to me.